Okay, Algebra 2, this is the video for Section 7 on transformations of quadratic graphs. We're going to look at how to graph quadratic functions using the vertex form. Okay, so the vertex form of a quadratic function is y equals a parenthesis x minus h all squared plus k. And our goal is to get our quadratic equation to look like this. When we do, it's going to give us some important information about the graph of our quadratic function. First thing, the h comma k that's in this equation is actually the vertex of our parabola. And remember, the vertex is either the very lowest point on the graph or the highest point on the graph. The a in front of the parenthesis tells us if the quadratic function opens up or down. If it opens up, then a is a positive value. When a is negative, then the quadratic function opens down. Okay, we also have an axis of symmetry, and so we'll see a few of those things as we go through the problems. Okay, so example 1 says to write y equals x squared minus 2x plus 4 in vertex form. So let me rewrite the vertex form again at the top so that we know what we're trying to get our equation to look like. So y equals a parenthesis x minus h all squared plus k. Okay, so this is our goal, to get our equation to look like this. So first thing you want to do is you're going to look at the first two terms within the quadratic equation, and we're going to see if we need to factor anything out of those first two terms. Now, I could factor an x out, but that's not what we're looking for. We're looking for a number that would be going into whatever x squared plus or minus whatever x. In this case, since it's a 1x squared, there's not a number that I need to factor out. So I'm just going to keep y equals x squared minus 2x, and I'm going to leave a space and then put plus 4 on the end. Okay, so the reason I'm leaving a space is so that I can complete the square here. If you see in the formula that I'm trying to get to, I have a perfect square, x minus h all squared. And so I need my equation to have a perfect square in it. So in order to do that, I have to complete the square. And we learned how to do that last week. So remember, you're going to take the number in front of x, which is a negative 2 in this case. You're always going to divide by 2 and then square it. And that's the number that's going to go right here in this blank. So negative 2 divided by 2 would be a negative 1, and negative 1 squared is plus 1. Now, because I'm adding 1 to this equation, I have to keep my equation balanced. So back here after the plus 4, I'm going to go ahead and put a minus 1 at the end. Okay, so really when I have a plus 1 and a minus 1, I didn't change the value of the equation anyway. Okay, so now I'm going to rewrite and simplify a few things. I'm going to erase this completing the square step because I don't need that anymore. And I'm going to write y equals, and we're going to write what's in parentheses as a perfect square. And then at the end, I've got plus 4 minus 1, so that's actually a plus 3 over here at the end. Okay, so remember when we completed the square last week and you wrote it as a perfect square, you always had an x, and then the number that you wrote after x was the number before you squared it. So when we did negative 2 divided by 2, that was minus 1, so that's what goes in the parenthesis here to complete the square. Okay, so what I have now is actually the vertex form of this parabola. And if I was going to graph it, I would want to know where the vertex is. Vertex is h comma k. So for this problem, it's the number in parentheses, and anytime you pull a number out of parentheses when you're finding the vertex, you're going to change the sign. So our vertex is going to be at 1, 3. Okay, so if I was going to graph this parabola, I could go to 1, 3 and put the vertex. I can also use this formula, and I can know that the axis of symmetry, which you know that an axis of symmetry is a line that's going to divide the parabola into two even pieces. In this case, our axis of symmetry is always going to be x equals h. So for this problem, that's going to be x equals 1. So if I went over to 1 on the x-axis and I could draw a vertical line through that, that would be the axis of symmetry that goes through this parabola. I could plot a couple of points on either side of it, and that would be my parabola. Okay, we're going to look at part B of example 1 here. And again, we're trying to get our equation in vertex form, and then we'll talk about the vertex and axis of symmetry that we could use to graph the parabola. So this one's a little messier, but that's okay. We're going to get through it just fine. I notice for this one that I do have a number that I could factor out of those first two terms. That's what you always want to look for. So I'm going to write y equals, and I noticed in those first two terms I could factor out a -3. So I'm going to write -3 open parenthesis. If I factor out a -3, then I would be left with x squared plus 6x. Notice it's a positive 6x because -3 times positive 6 would be the -18. Okay, I'm going to leave a space and put my closed parenthesis and then put plus 10 on the end. What I need to do is complete the square again. So we're going to look at our number inside the parenthesis here. We're going to take that number, divide by 2, and then square it. That's the number that's going to go right here in this blank. So 6 divided by 2 is 3, and 3 squared is 9. So this is plus 9. Okay, now this time, the number that I add or subtract at the end of the equation is not just going to be a -9. Okay, what happened on this problem is that I have a -3 over here out in front of parentheses that is actually being multiplied times this 9. So -3 times 9 is a -27. I actually added -27 to the equation. So over here at the end, I need to put a positive 27 to balance my equation out. Okay, so I'm going to erase my purple writing here again. And we're going to clean up our equation a little bit. So y equals, I'm going to keep my -3. I'm going to rewrite this as a perfect square. And then on the end, my plus 10 plus 27 is going to be plus 37 on the end. Okay, so what goes in parentheses is going to be x, and it's the number before you squared it. 6 divided by 2 was plus 3. Okay? So for this problem, this -3 out front tells me that this is actually going to open down since it's negative. I know that my vertex would be at -3, positive 37. Remember I said when you pull the number out of the parenthesis, it's going to change the sign. And my axis of symmetry for this would be x equals -3 as well. Okay, this example 2 says, which is an equation of the functions shown in the graph? So I have a graph of a parabola, and I'm going to label a couple of things that are on this graph that we've been talking about, but I hadn't shown you a picture of. So the vertex is always the very lowest or highest point on the graph. So here, our vertex is at +2, -3. Okay, The axis of symmetry is the line that goes through that vertex and actually splits the parabola into two equal pieces. So this is the axis of symmetry, and it is at x equals 2. Okay, we can see that our parabola opens up, so that means we should have a positive number in front of our equation. And then we could use some of the points that are on this graph as well. So I'm going to look at my answer choices here, and I'm going to eliminate some that don't make sense for what we have so far. So I've already said that our parabola opens up, so that means we should have a positive number in front of our equation. So I'm going to cross out choice A and choice C. And then when I'm looking at the vertex, when we look at it in vertex form, remember the x value is going to change sign in the parentheses. So both of these have the vertex at 2, -3 that is correct. Okay, so one way to check which one of these is the correct equation is for me to find a point that is on this graph and then to plug it in to the equation. So here's a point right here. This is 0, -1. So if I plug in 0 to this equation B, and I do 1/2 of 0 - 2 all squared minus 3. I want to see, does this equal -1 when I simplify? So we've got 1/2 times a -2 squared would be a +4 minus 3. So then 1/2 of 4 is 2 minus 3, which is a -1. So we did get 0, -1. So just for fun, I'm going to show you on equation 2 that we would not get the right answer. So for this one, if I plug in 0 for x, and I simplify, this would be 2 times 4 minus 3. We know that 2 times 4 is 8. 8 minus 3 equals 5. And I know that 5 is not equal to -1. So that's how I know that equation D is not correct also. Okay, so in this picture that I've got up here, this is showing the different transformations for quadratic functions using that vertex form. So h is the number that's going to shift a graph either to the left or to the right. That is the x-coordinate of the vertex as well. And it always goes the opposite direction of what you would think. So in parentheses, if it was x plus 2, it's actually going to go to the left 2. X minus 3 is going to go to the right 3. The k at the very end of the equation is the vertical translation, so that's what's going to shift it up or down. And that's always going to do what makes sense. If it's plus a number, it's going to go up, minus a number will go down. A in front of the equation has to do with the reflection and the dilation of the graph. What that means is if the graph opens up or down, and like I said earlier, when A is positive, it opens up. When A is negative, it opens down. The value of A determines how wide or narrow the graph is. And when A is greater than 1 or a bigger number, then it's actually going to be a very skinny graph. When A is a fraction, it's going to be a very wide graph. So it does kind of the opposite of what you would think. Okay, so we're going to do another example, getting the equation in vertex form, and then we're actually going to graph this one. So you always want to start looking at those first two terms and see what number you can factor out of those terms. So y equals, I notice I can factor a -2 out, so I'm going to put -2, open parenthesis. So if I factor a -2 out, I'll be left with x squared minus 2x. I'm going to leave a space and then put my +1. I need to complete the square, so I'm going to take the number in the middle of the parentheses, the -2. I'm going to divide by 2 and then square that number. So negative 2 divided by 2 is going to be negative 1. Negative 1 squared would be a positive 1. I'm not going to put a minus 1 outside the parenthesis because I have this number out in front of the parenthesis. Negative 2 times the positive 1 is a negative 2, so technically I added a negative 2 to this part of the equation, so I need to put a plus 2 out here on the end. Okay, so now I can write my equation as a perfect square. So y equals negative 2 parenthesis, I'm going to write this as a perfect square. This is going to be x, and then the number before I squared it was a negative 1. And then out here on the end, 1 plus 2 is plus 3. Okay, so here's our equation in a vertex form. Now we're going to look at the information that we need in order to graph it. So I know that this opens down because of the negative that is in front of the parenthesis here. I know that the vertex of this equation is going to be at positive 1, positive 3. And I know that the axis of symmetry is going to be at x equals 1. So that's going to help me graph. I'm going to put those on a graph first, and then I'll plot another point or two. Okay, so I'm just going to draw my own coordinate plane here. Got a lot of messy stuff written on top of there. Hold on, let me clean that up just a second. Okay, now that I can see my equation better. Okay, so we're going to start with the vertex, which is at 1, 3. So I'm going to go over 1 and then up 3 spaces and put my vertex. I know that my graph is going to open down. I also know that the axis of symmetry is going to go through that point, so I'm going to draw an imaginary line that'll help me in just a second so that I know it kind of divides it into 2 pieces. Okay, so what I also like to do is get a couple of other points to be able to plot on here. Okay, so if I want to pick something to the left-hand side of the graph and something to the right-hand side. So let's plug in like negative 2 into this equation and find out what y equals. So if I plug in negative 2, this is going to be negative 2 times negative 2 minus 1 all squared plus 3. So let's simplify and see what y equals. Negative 2 times negative 3 all squared plus 3. So then this would be negative 2 times 9 plus 3. Negative 2 times 9 is going to be negative 18 plus 3 is going to be negative 15. So what that means is over here at negative 2, the graph goes way down to negative 15, which is probably off my graph. We're just going to pretend that's negative 15. Okay, then I could do something on the right-hand side of the graph as well and pick like positive 2. If I plug in positive 2, what happens? So let me erase this work and let's plug in positive 2 this time. So if I do negative 2 times 2 minus 1 all squared plus 3. So this would be negative 2 times 1 squared plus 3. Well, 1 squared is still 1. Negative 2 times 1 is negative 2 plus 3. And that's just going to equal 1. So at positive 2, it's equal to 1. So right here, here's my point right in there. Okay, so that just gives you a guide as to a couple of extra points. So this is going to be a real skinny